All right, this will be our third and hopefully final video for 12.3. If it takes us more than another video, we're in trouble. All right, so the last one, we ended with the finite geometric sum for geometric sequence. Well, now let's look at an infinite. So we're adding up an infinite amount of numbers, which to me is a really interesting concept, especially because it's going to do one of two things, which is weird because you wouldn't think you'd only think it would go off to infinity. If you have an infinite amount of numbers added together, wouldn't it just be infinity? Well, sometimes. So these infinite series, even if it's not geometric, they're either going to converge or diverge. So if it converges, the sum approaches and attains a numeric value. If it diverges, the sum is either infinity, like if you're adding up all positive numbers or the positives overtake the negatives, or it'll go off to negative infinity if the reverse happens. So if you have trouble kind of trying to remember, well, which one is which, think of that movie Divergent and kind of the basic premise of it. The main character was Divergent because she did not fit into one single category. And that's kind of what Divergent means. It's not going to actually collapse or go to one thing. It's just shooting off towards infinity. It cannot decide on what it is. Everybody else converged to one faction. So they picked one thing to go to, and that's what they were. So that's kind of the difference between converging and diverging. So a geometric series, it'll converge if and only if that ratio, if you take its absolute value, it has to be less than 1. So if it is, it's going to converge to this sum over here, a over 1 minus r, which is still interesting to me that you can take an infinite amount of numbers and add them up and it comes out to like 22 instead of infinity. So let's see how these go. So determine if it converges or diverges. If it converges, find its sum. If it diverges, don't find the sum. So all you want to do is look at the r. Look at the power, or the r that's in there. The r has the power on it. So in this case, r is 3 over 2, and that's greater than 1. So that means it diverges. And that's all you have to do. Part B, the r is 3 over 4, which is less than 1. Well, if it's less than 1, then it converges. And so the sum is going to equal, we're going to follow that formula. So the a is 2 over 1 minus 3/4. Well, what's 1 minus 3/4? Well, it's a fourth. 2 divided by a fourth is 8. So you're going to add up an infinite amount of numbers and it's going to come out to 8. Isn't that cool? Why, yes, it is, Professor. All right, let's look at this one, part C. Uh-oh. This is kind of meant to trick people. Dun, dun, dun. Because what do you notice about the exponent? That's right, it's backwards. So let's flip it around to the way it's supposed to be. So it's supposed to be k minus 1, so I just switched the signs. Well, if I'm switching the signs, that means I've just taken the reciprocal of the r. So my r is really e, which is greater than 1, so it diverges. All right, and there was a little typo in this one too. That should have been a k equals 1 in part D. So this one, if you notice, it's a little bit different as well. The exponent is a k. So we're going to do that little trick that I did earlier. I'm going to split off a 3/4 so I can make my exponent the one I want. So my r, excuse me, is 3/4 again. So I know it's going to converge. And now I can get the sum. But the sum is going to be everything that doesn't have the exponent on it. So it's the 2 times 3/4 or the 3/2. So we have 3/2 divided by 1/4, which is going to equal 6. And there's your infinite geometric sum. So I have one last example for this section, and it's kind of a mind blower. I had one student years ago who just did not ever believe this. But we're going to show that 0.9 repeating is equal to 1 using a series. So I'm going to start out by taking that 0.9 repeating. I'm going to kind of write out what that actually means. So 0.9 repeating is just 0.999999999 on forever and ever and ever. So we're going to show that this decimal here is really 1. So it's going to equal, I'm going to break this up into individual 9s by saying that's like 0.9 plus 0.09 plus 0.009 plus 0.0009, on and on and on and on forever. Because writing it this way, I've just turned it into an infinite sum, and it's geometric, because my a would be 0.9 or 9/10, and the r is what I'm multiplying each time to give me the next term. So I'm just like adding in an extra 0, so my r is really 1/10. So I have the sum from k equals 1 to infinity of 9/10 times 1/10 to the k minus 1. So that's really what the sum is. And I know it converges because the r is less than 1. So let's use that sum formula. So the a over 1 minus r. So 9/10 divided by 9/10 is equal to 1. So you just showed that 0.99999 on forever equals 1. All right, so that's going to do it for geometric sequences. Go ahead and try the homework out and let me know if you have any questions.